Hello CIS 2110 students. I wanted to go over very briefly one of the more complex topics in chapter 1 of our green book. Most of this chapter is pretty straightforward. It's a lot of definitions. There is some stuff about how computers work, but we're not going to be testing on that. It's more for your background information. But one thing that will be on the test is binary. So I wanted to show you that. One thing to know about computers is just at the most basic level, computers keep track of bits, and a bit is a single digit, and it's either going to be a 0 or a 1. And the 0 or 1 simply indicates whether something is on or off. And the way that this works is if you have a series of bits, and in this case we have 8 bits that form a byte, and that's pretty much the standard protocol. A byte is read from right to left, and each position in the byte stands for 2 to some power. So the first position on the right side stands for 2 to the 0, or the number 1. The second position stands for 2 to the 1, or 2. The third position is 2 to the 2, or 4. Fourth position, 2 to the 3, or 8, etc., etc. So the position tells us the number that's represented, and the 1 or the 0 tells us whether or not that number is turned on or off. So down here at the bottom, I can see that the 1 position is turned on, so I will include that. The 2 position is turned off. I don't include it. I just write in 0. We're not going to include the number 2. 4 is turned on, 8 is turned on, 16 is turned on. So I will include 4, 8, and 16. 32 is turned off, 64 is turned off. So I don't include those in my calculation. 128, 2 to the 7th, or 128 is turned on. I will include that. And to find out what this number 1001, 1101 means, I add up the numbers that are turned on. So 128 plus 16 plus 8 plus 4 plus 1, and that is equal to 157. So the number 1001, 1101 is equivalent to the base 10 number 157. Usually humans think, or at least in the Western world, we think in terms of base 10. Computers, though, don't like to think like this, and we ask, why would that be? Well, if I want to represent the numbers 0 through 9, I have to come up with 10 signals to do it. But if I only use binary, I only have on and off. It's like a light switch. It would be either on or off, up or down, true or false. Computers don't want to have to handle 10 different signals. They only want to be able to handle 2. You can see that this isn't efficient with smaller numbers. I have to use 8 digits to represent what in base 10 would be a 3-digit number. However, as I start to get higher and higher on the numbers, that reverses. And by the time you get out to some of the numbers that are stored as 128-bit bytes, that number, if all the numbers are turned on, represents more atoms than are present in the entire universe. It's a huge number. And we can represent that number with only 128 spaces. It would take an entire lifetime to write that, even just to write the number out. 2 to the 128th places is a massive, massive number. So it's actually more efficient with big numbers. So on the test, you will be given a binary number, and you will be asked, convert this and tell me what is the equivalent base 10 number. I just showed you how to do that. You just write out your numbers and say what's turned on and off. And you'll also be given a base 10 number and asked what is the equivalent binary. Now that's shown in the book, and I've also posted a binary calculator on Blackboard for you, or whatever we're using this year at Metro for our online learning environment. If you have questions, ask me, but for now, that's what you need to know on that. There's a good video. This is our notes for class. This is the chapter 1 notes, so you have access to this link. And all you got to do is Google binary tell me about, or basic binary, and you will find tons of good videos on YouTube. We will not be testing about other types, oct, hex, any other bases. Oct is a base 8, hex is base 16. We're not going to have that on the test. It's only binary and base 10. The reason that you want to know about this is that this is how computers will send a letter. And what they're doing is they can, once I get a binary and a number, I can translate it to the equivalent base 10. And then you and I can set up a system where we'd say, if I send you the number 1, I'm sending you the letter capital A. If I send you a 2, I'm sending you the letter capital B. If I send you a 3, I'm sending you the letter capital C. So if I send you 3, 1, and then I think it's 20, I'm sending you the word cat. Okay? Very simple, and you will sometimes see that somebody talking about something on ASCII text. ASCII is just the protocol that says what we map a given number to. For example, and I haven't looked up ASCII in a long time, but you'd say 1 is equal to big A, 2 is equal to big B. Go through the rest of the alphabet. Then 27 is equal to lowercase a, 28 is lower to lowercase b. Go through all the lowercase letters. 53 is equal to a period, 54 is equal to a comma, 55 is equal to an exclamation mark, whatever you want to mark, whatever you want to say. It's very easy to send letters, and you can send the entire alphabet, uppercase and lowercase. You can send any symbol you want, and all you have to be able to do is send one of 2 signals, and you really only have to send one, because if it's left off, that can be a signal too. So by sending either on or off, you can literally send an infinite number of signals, but it does take some coordination. You and I both have to understand what we're trying to send through the system. I hope this helps you understand binary. Please send me an email if you have any other questions. The rest of chapter 1, like I said, is pretty straightforward. It's a bunch of parts of a computer. It is the parts explained. It's a lot of terminology. So let me know if you have any questions. Otherwise, as long as you're learning those terms, and if you've studied the course introduction website, or not the website, the handout, I do give a ton of information there about how to take effective notes, and this is what we're talking about. We're just trying to get down these basic terms and concepts. Send me an email if you need any help. Have a great day. Take care.